Okay, so as in the last video we have discussed about the electric flux. What was that? It was the number of electric line of force passing through a very small element of vector area is called electric flux. And in second definition we have talked about its product. It was the dot product of electric field intensity and the small element of vector area. And we know that when we have a dot between the two vector quantities, the answer of the dot product of two vector quantities will always be scalar. So we know that, and we have got that electric flux is a scalar quantity since it was the dot product of the two vector quantities, the one electric field intensity and another vector which is a small element of vector area. So we have got that electric flux was a scalar quantity. In today's video we're going to drive its unit as well as the dimension. What is the dimension of electric flux and what is the unit of that? So we are going to take out the unit of this. Taking out or driving the unit. Taking out the unit of electric flux. Electric flux. Alright, we are gonna take out the unit of this. So this is our topic. Alright, so we know that it is the dot product of electric field intensity. Phi is equal to electric field intensity is the vector quantity and is the dot product of small element of vector area. Alright, we know that the unit of electric field intensity, we have derived that. Alright, and we know that electric field is the force per unit charge. So electric field is nothing but it was force per unit charge, and we know that the unit of force is what? It is Newton. It is Newton, and the unit of charge is Coulomb. Newton per Coulomb, which we can also write like N per C, which is Newton per Coulomb, was the unit of electric field. However, now the unit of area, we know that area is what? It is length into breadth, and the unit of length is meter and the unit of breadth is meter as well, and meter into meter is what we get, the meter square. So the unit of small element of vector area is meter square and the electric field is Newton per Coulomb. Alright, wait, let me highlight this. Wait, let me highlight this, then we're going to drive its unit too. Alright, so now phi is equal to, we have the unit of electric field intensity, that is force per unit charge, which means I can write as Newton per Coulomb. Alright, or I can write initially like this: force per charge is the formula of electric field intensity. We know that electric field intensity is equal to force per unit charge into small element of vector area. Alright, so by this we got that force, the unit of force is Newton per the unit of charge is Coulomb, and we know that the unit of area is meter square. The unit of area is meter square. Alright, if I'm gonna break this meter into 2 meters, that is fine. Okay, so phi is equal to Newton per Coulomb into meter. Alright, I know that is fine at all if I write Newton meter into meter, because meter into meter is called meter square. And now we know that Newton into meter is equal to joule, and that we have discussed in the work, right? We know that work was the dot product of force and displacement, and the unit of force was Newton and the unit of displacement was Newton meter, and the final unit of work was joule. Alright, so we know that Newton into meter is equal to what? It is equal to joule per Coulomb into 1 meter remaining. Alright, now we know that joule per Coulomb is equal to volt. Joule per Coulomb is equal to volt. So instead of writing joule per coulomb, I can write volt and same meter. So the unit of electric flux is volt into meter. The unit of electric flux is volt into meter. Let me highlight this now. Alright, so now we're gonna take out the dimension of this electric flux by using the unit of it. Alright, we know that the unit, here I'm not going to take here I'm not going to use the this unit volt into meter. However, I'm going to use the very simple unit which we have just derived right now, which is force per charge into meter. Force per charge into meter, because we know that it was the dot product of electric field intensity and the small element of vector area, which means meter square. Alright, and that was equal to phi, which means electric flux. Electric flux. Wait, let me highlight this too so that I cannot create any confusion. So force per unit charge into meter square. I know that the dimension of force, wait, let me take that out, right? I know, but I guess you guys don't know the dimension of force. So wait, we know that force is the product of mass and acceleration. F is equal to ma, and we know that the mass is m and acceleration is equal to meter per second square. Meter means L, second square means per second square means t minus 2. So this was the dimension of the force. As you can say, Newton is equal to ml t minus 2. So wait, alright, so we know that phi is equal to force per unit charge into meter square. Alright, and force we know that is equal to m into a upon q dot meter square. Alright, meter square. So phi is equal to, now what's the unit of, or you can say what is the dimension of ma, that we have taken out already. Alright, so that is, wait, instead of this q I can write coulomb, right? That would be fine, because we know that the unit of the charge is coulomb. So meter ma, we have already taken out the dimension, and that was equal to m L t minus 2. Alright, into, now see, m square means L square, so L square upon what we have, upon we have coulomb, and we know that coulomb is equal to ampere into second. Coulomb is equal to ampere into second. Wait, let me highlight that as well. So ampere into second, which means I can easily write A and second as T. Alright, A is representing here, you know what, the ampere, and T is representing here the time, which is second. Alright, now if I'm taking these both as up, they're gonna take the minus sign. So M, this L and this L. So L1 and L2 means L3 and T minus 2 same. Alright, when this A will gonna go up, it will gonna take minus sign. So A minus 1 and T also minus 1. Now see, M, L3 same, T minus 2 and minus 1, which means minus 3, A minus 1. So what is the dimension of this, you know what, dimension of electric flux is ml3 t minus 3 a minus 1. This is the dimension of electric flux, which we have just derived now. Electric flux. Alright, so today we have discussed about the unit. What is the unit of electric flux? That is equal to volt in 2 meter, and we have derived the dimension as well, and the dimension of electric flux is ml3t minus 3a minus 1. Alright, so this was all for today. In the next video we're going to discuss about its angle. What will be the angle between electric density and the small element of vector area, and then what will gonna it create the effect on the electric flux.